Hello fellow problem solvers. So today we're going to be doing a problem from the Italian Math Olympiad from the year 2000, problem number 2. Nice geometry problem. If you're getting comfortable with geometry somewhat a little bit, you might want to attempt a G1 soon-ish. Tried this before. And I suggest you try this problem out for a minimum of 20 minutes, ideally 30 to an hour, maybe an hour and a half, not more than 2.5 hours, just not more than that. If you'd like to go along with us, give us a go for the next 5 to 10 minutes. Try to draw a diagram and say, wacky sort of problem statements you're seeing here just at the beginning. And now let's begin. So how do we draw this? Well, okay, let me first draw the alpha, which is DAB. So let me say DAB, DA and B somewhat here. And then I want to draw these other angles. What do I need? What are the conditions? I have beta, which is going to be like dB is beta. And then gamma is 90 minus beta, and gamma is ACB. So I'm going to have a C here. It's like on a circle over here somewhere. And then I have this angle is epsilon. And I have epsilon plus 2 epsilon plus delta is going to be 180. So pi is 180, this is 90. And what does that mean? So that means that this delta angle, which is the angle DBC, so this angle is going to be 180 minus 2 times epsilon. So how do I think of that? Well, I think of that as if I extend this here, and I draw an epsilon here, this is where C is. So I have C here, and I have, say, over here is going to be 90 minus beta. Okay, and now we have our triangle. Now, what I would just do here is I would pause for 5 minutes and ask yourself, what is the thing that you're going to say is your center, like thing that you have defined, with respect to which other things are defined? I mean, it's a weird question I'm asking, but what I'm trying to get at is that for me, how I'm thinking about this is I have a triangle ADB, and then this point C is added with these two conditions. Right, so let me just call this angle gamma instead of epsilon. I'll just rename the angles just so this is more familiar to me, because I know these are elements of the triangle. Maybe I can find something interesting there, maybe something that I know from some previous problems. So what do we have? We have gamma is going to equal this angle plus 90 minus beta. So this is going to be beta plus gamma minus 90, which, because alpha plus beta plus gamma is 180, that's going to be, okay, so this is 90 minus alpha. Okay, because this whole thing is alpha, this is going to be 2 alpha minus 90. Okay, 90 minus alpha, where do I have it? Well, I have it when I put a height down from here or from here. I have some sort of Pythagorean theorem, like it's really telling me looks like Pythagoras here, and I have a 90-degree angle condition. So maybe there's something to that. And here is where I ask you to pause for the next 10 to 15 minutes and try to push the problem further, put some ideas out there. And for me, the first idea I came up with was, okay, this is gamma. Then if I draw like a 90-degree a line that's perpendicular to AB and goes through B, it will be an angle bisector as well. And then there might be something maybe intersects this here at point E, and then I might get something, but I got AB squared plus BE squared, which is hard to connect. I'm not really connecting it to anything just yet, to these other elements. And then I saw, wait a second, can I do this trigonometrically? The answer is yes. But actually, before I did the trigonometry, I was thinking about other things to make this look like Pythagorean theorem. I need a 90-degree angle. How do I construct a 90-degree angle? And there are two ways to think about this. One way is I have beta, I have 90 minus beta. I want to do what? Add them up. How do I do that? Pause for 5 minutes, think about how would you do that? And for me, the thing is, okay, I can either construct a 90 minus beta here, and then I get similarity, but it doesn't really end up working out for me. Okay, so back to the drawing board. What else could I do? Well, I have a gamma 90 minus beta. What if I reflect D over here with respect to AB to the point D prime? Then I have beta here, and I should get some other angles, but I have beta. I have A, and this angle is like, now I want it to be 90-ish. And once I actually think about it, wait a second, this is gamma. This is 180 minus 2 gamma. So C, B, and D prime are collinear. Oh, so I do have this angle. This is alpha, a reflection. So this whole thing is 90. And now I have AD squared here, AD squared, AD prime squared, plus AC squared is equal to D prime C. So actually, let me write this down. I get AD prime squared plus AC squared is equal to D prime C squared. Now, what is this? Well, this is AD squared plus AC squared is equal to D prime C. Well, that's D prime B plus BC. D prime B plus BC squared. I have a BC, so I need D prime B and DB to be equal, which they are because this is a reflection with respect to this. So this is DB plus BC. And this proves our problem. It's very painless if you do it like this, right? There's no major computation happening. It's just one idea, boom. Now a different idea. Instead of this point, I was thinking, okay, wait a second. This is 90 minus alpha. This whole angle is alpha. I want a 90-degree angle. Well, let me do this. Now I'll have a 90-degree angle and I'll have an angle bisector. And I'm saying, wait a second, I have 90. I have 90, so this is 90 minus alpha. What do I have? Well, I also have, mind you, this here is an angle bisector. So what I want to do is I want to intersect these two. And now what do I get? I get 90 minus alpha. I get this is 90 minus beta, right? Just because this is gamma. The same sort of logic that we had here. 90 minus beta, 90 minus alpha. So this, so these two triangles are similar, but because they share AB, they are congruent. Which means what? Call this point E. It means that AE is equal to AC, and also BE is equal to BC. And now, same thing we did before, AD squared plus A, now we have this Pythagorean theorem, AD squared plus AE squared is equal to DE squared, which is equal to, what is DE? It's DB plus BE. BE is equal to BC, so this is equal to DB plus BC squared, what we need here. And on the other hand, we have AE is equal to AC, so this is AD squared plus AC squared. And this finishes up the problem in a different way. Now, some of you may have said, wait, just do trigonometry, I get you. You can calculate everything here. It's okay. But the idea is sometimes you want to have both. You want to know how to do trigonometric calculations, sure, but you also want to get these ideas for reflections, putting in new points in geometry, because sometimes that is really what is at the crux of the problem. You need to introduce a new point which really just breaks it all down. Because trigonometry, yeah, sure, you'll be able to do that maybe on an IMO 2. Sometimes, though even that's questionable, it might be very rough, but you could maybe do it even on IMO 2 or 5. IMO 1 or 4, probably-ish. But if you're going on a problem 6 or 3, it's no longer 2013. It's going to be very, very difficult for you to just do plain trigonometry and finish the problem. I find that to be much more a difficult thing to actually bet on that. I wouldn't bet on that. So that's why I would try to, these easier quote-unquote problems can help you develop the intuition for how to get ideas for harder problems. Now, onto the trigonometric solution. What do we have? We need to calculate what we need to calculate. BC, DB, AD, AC, all with respect to the elements of the triangle. So what do we have? BC is going to be what? It's going to be, okay, cosine of alpha, looking at the sine of this triangle, cosine of alpha times, okay, say cosine of beta over AB. So now let's do everything with respect to AB. What do we have? So this is BC. What do we have? We have DB is going to be equal to DB is sine of alpha over sine of beta times AB. Okay. What else do we have? AD. AD is going to equal to sine of gamma over sine of beta times AB. And what do we have? AC. Again, now here we have sine of gamma over, again, let's do the same thing, cosine of beta times AB. And now, this is equivalent to, once we just like plug in these trigonometric substitutions, AB cancels out. We get cosine of alpha over, what do I have? Cosine of alpha over cosine of beta, sine of alpha, sine of beta. Cosine of beta, plus sine of alpha over sine of beta squared needs to be equal to sine of gamma over sine of beta, sine of gamma over cosine of beta. Okay, so sine of gamma squared times 1 over cosine squared of beta plus sine squared of beta. Okay, so this is what we have. What does this turn into? Well, we have sine of, we'll get cosine of alpha sine of beta plus sine of alpha cosine of beta. What's that by the trigonometric rule? It's sine of alpha plus beta, which is 180 minus gamma. Sine of 180 minus gamma, which is sine of gamma. So we have sine of gamma squared up here. Here we have sine of beta, cosine of beta. And this needs to be equal to sine squared of gamma times 1 over cosine of beta plus sine squared of beta. What is this? Well, when I actually multiply them through, I'll get sine squared of beta plus cosine squared of beta. What is that? Sine of x squared plus cosine of x squared is equal to 1. That is correct. So I'll get 1 over sine squared of beta, cosine squared of beta. And, oh yeah, I forgot to say this is squared. So that now these two things are the same, and we've proved the problem. It's a lot less creative, mind you, it's more technical. Also good to practice that. If you're not good with trigonometric sort of solutions, you know, this is a good thing to analyze, just like how we calculated everything with respect to the elements of the triangle, the sines and cosines of alpha, beta, gamma, and AB. And just finish the problem. Because once you get that, you need to be able to finish the problem, right? It's only a matter of technique at that point. And this shows, 3 different solutions to this problem. And there are a lot more ideas that I tried out that just plainly didn't work. For example, I tried this thing, didn't work. I tried this thing, which I mentioned in the beginning. These ideas did not work out, and you're trying out different sorts of things. You try boom, bam, bam, and sometimes it might work out. Oh, why do I have reflex? You get a sum of 90, and it ends up working out. Now, there can be even deeper thinking, but this deeper thinking deeper thinking in the sense, okay, I have a gamma, 90 minus 2 gamma would be really nice if, okay, I can extend this. Well, I have an angle bisector. I need AD to be on this side. I need either AD or AC to be on this side of the Pythagorean theorem. Okay, so I should probably reflect there's some deeper thinking perhaps that you could go down, but it's not, mind you, that comes with time. You shouldn't try to stress too much about trying to understand the depths of how you come to a solution just at the beginning, but more so you're starting off with building up an intuition with problems, and then you can, you see these patterns again and again and again, and then you realize, oh, wait a second, I've seen something like this before, this sort of reflection. And that's why it's useful also, because you might get to a very hard problem and it says, oh, it's that reflection again. Let me try that reflection. There's something in the back of your mind, maybe it's not conscious, but in the back of your mind, which tells you, oh, let me reflect. and that solves your problem. And as always, thanks for problem solving.